This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Is problem solving, so finding a problem and having a computer solve that problem using programs. Everything that we design here in this class for this module are very small programs, right? So if you do 1,000 lines of code, that's still considered a very, very small program. Most programs can go up to millions of lines of code for things that actually do something quite important. But everything here, in fact, the programs that we'll be creating here throughout the next 12 odd weeks are tiny, minuscule programs, just little samples of how to use the programming language, basically. A quick off the cuff, just to sort of lighten up the mood. You may see me over the next 4 weeks going from brown hair to grey hair. Okay, and it's got nothing to do with you guys, okay? I actually have grey hair, and 2 weeks ago I went to a pirates party and I had to do fancy dress, so my family dyed my hair brown. So the next haircut I have, I'm sure it'll be back to how it should be, which is grey or white. So don't feel bad, okay? It's not your fault. It's just the way it is. So we'll be covering good practice, sort of how you should program, what is expected, and the way to code in a way that makes you professional. Because the idea will be that I'll be certifying that you guys, when you leave and you pass this course, I will be certifying that you guys can code in Java, at least to a moderate level. And in so doing, you do need to have good programming style. So there's a certain style that's expected within industry and that you'll be expected to follow. We'll be looking at good documentation habits, and we'll be following basic specifications. Oh, excuse me. Point to notes, by the way, if I miss anything, if you feel that I've missed the point, my system lost the proper slides this morning, so I'm using a PDF, same PDF that I'll be uploading at the end of this lecture for you. So if you feel like I've skipped a step, it's mainly because I don't have notes at this particular time, but it's pretty basic stuff, so there shouldn't be anything too difficult anyway. So there's a little statement or a little quote that a computer is like an Old Testament God with a lot of rules and no mercy. Now, what's meant by that is that a computer, when you're doing a program, it either works or it doesn't. There's no in between, right? You can't have a program that doesn't do what you expect it to do, because it will break. Java is very sort of prescriptive in the way that you need to use the language. I'll be asking, how many of you guys did Python last semester? Okay, just a few. How many people did? How many of you guys have done Python at all? Okay, few. I was thinking. Okay, so Java is it's not harder than Python, but it's different in the way that it's more prescriptive. It forces you to follow certain protocols that Python lets you get away with. So with Java, I like it more because it's very exacting, it's very specific, and you have to do things in a certain way. And that, to me, keeps me in control of what I'm doing, whereas Python will do things for you, and sometimes won't tell you that it's done it, so therefore you won't get the same benefit of knowing what exactly is going on in the code, right? So that's what this quote basically means, is the sense that there's tons and tons of rules, and it's unforgiving if you make a mistake, so it'll just fail, right? So we've got 12 two-hour lectures. Generally, most lectures that I've been teaching are 1 hour, and they have a gap in between. So what I'll do, roughly within 1 hour of this lecture, which will be about 3:15, we'll have a short break. And the recording started now. I don't know when it started, so whoever's listening online now, sorry, it didn't start on time. I don't know why. Anyway, so I'll have to look at that and see what time it started so we can do the same next week. So we've got 2 hour lectures. We'll have a short 5-minute break in between, like an interval. That'll give you time to go and have a drink or some toilet break or something. Now we have like a billion workshops. I don't know if you've looked at the timetable, but there's loads and loads of workshops. The workshops are not live yet. There's a situation taking place where the rollover hasn't happened. So by next week, by the time Monday comes next week, the tutorials, or they're actually labs, they're not tutorials, will be running and up and ready for you. So they're 1-hour workshops. Now, everyone should have already sort of put themselves down for a workshop. And if you haven't, obviously you should do that very, very quickly. In terms of the workshops, now, I don't mind which workshop you take. It makes no difference. In fact, you don't even have to sit the workshops in the workshop. And what I mean by that is the first thing the university this semester is trying to push forward is the bring your own device scheme. So a lot of the workshops are where you bring your own device. I'm an advocate of this. I think this is a great idea because often you can then work anywhere at any time on the work that you have, on the labs that you have, and you're all set up. Whereas if you leave it to the lab computer, you know, you've got to go there, you've got to log in, you can't work at your own leisure. So essentially, if you're scheduled for, say, I don't know, Monday at stupid o'clock, like 8 or something in the morning when you're supposed to be asleep, if you don't want to sit that, you can try and go to another lab. That's perfectly fine. However, whoever's already scheduled for that takes priority, right? So if it's full, if you go and speak to the demonstrator and they say that there's no room, then obviously you have to find some other time that's suitable for both of you. At the same time, if they wait a few minutes and there's plenty of room, then you're welcome to join that tutorial lab as you feel is comfortable. So again, there's no onus. You don't have to do the labs, but I would give you a warning, right? If you don't do the labs, you're not going to gain enough from the subject to be able to feel confident at the end of it. Essentially, which I'll go into in more detail, if you don't practice, like with any language, spoken language, you can't learn the language. Just understanding it when I'm speaking is one thing, but practicing it is how you will sort of bring that internally into yourself so that you can understand how to recreate it. It's a funny thing, the projector is really, really bright in my eyes there, so I might actually have to stand over here. I won't, but it's a funny lecture theatre. So all I can see is a big bright light in front of me. No, still the same. So assessment. Okay, so you have project work, which I'll go into in more detail on the next slide. 40% of your mark is from project work. You have to get 20%. Oh, sorry, not 20%, 50% of those marks, so 20 marks out of that 40 to pass. And the same with the exam, you have to get 30 marks out of the 60 to pass. So I believe both are a hurdle. I've had the situation twice in 2 years now where the information on the, what's it called? Not the timetable, the handbook is different to what I'm telling you. And in that case, we follow the handbook because that's what is right. It's not, well, that's what we have to go by because that's kind of the law, if you will. But my understanding is, and from what it should be, is that both project work and final exam are both hurdles, right? So you have to pass them to pass the subject. And all assessments have to be individual. I'll get into this later when we talk about the plagiarism aspect. The textbook for this course, I will be following Absolute Java quite closely. So if you want to buy the textbook, by all means buy Absolute Java. I'd also recommend, having used both myself in depth, Big Java and also Java How to Program are also very, very good books. You don't have to buy the book. I know how expensive books are. In the UK, I swear to you, UK books are like pennies. You can buy a book for $1 or $2. Right? I came here and I was like, what? Are you serious? I don't know why, but books are expensive here. I'm glad I brought a ton of books with me. But anyway, so if you don't want to buy the book, that's okay. I don't think you'll be disadvantaged in terms of your assessment. So you'll learn enough from the lectures and from the labs to be able to pass the course very, very well. I just feel sometimes that books, to me, having a textbook is a really useful aid to sort of extra learning, to kind of giving you that full in-depth knowledge that we won't be covering everything here. So in terms of coding, we won't be doing anything seriously advanced. It is just teaching you Java from nothing to being able to code reasonably well, with the ability to develop that coding further as you practice more, right? So the assessment. You will have 5 assessed exercises, but only 4 will be marked. Okay? How does that work? Essentially, we are tested 5 times, and we take your 5 highest marks, and that's what you achieve. If you've already got your full marks by 4, you don't have to do the final one, right? Because you've got your marks, because you will lose one of them anyway. So I would still recommend that you do all of them because you're here to learn. I was going to ask, actually, is there anybody here, I know if I get a hand up now I'll faint, but is there anybody here that doesn't want to learn? Yeah. Yeah, so everyone's here to learn. So I would still advocate you do all of your assessed exercises just for the learning process, right? You just want to learn more and more and more. And I was like that, and I've always been like that, and I feel that's what you're here to do, so hopefully you feel the same way. But at the same time, once you've got your 4 full marks, if you've got full marks for 4 of your assessments, you can relax at least. You don't have to panic. You know that you've done well in that particular assessed exercise. Yeah, so we drop we drop one of them, which essentially you'll have 20 marks in total for your 5 assessed exercises. Then you have one larger project. It's going to be around week 10, but it could be a little bit earlier, a little bit later, depending on the holidays and how it falls. That's worth 15 marks. So that's a big project that you'll be working on individually. I'll go into that in a minute. Anyone who was with me last semester on Python will understand where I'm coming from when I mention that. So on the 5 assessed, the first small 5 assessed labs or tutorials, the most important thing is that it works. You will not be judged on the quality of your code, the style. You won't be judged on your commenting, unless it specifically states this. Your main priority is that you will be judged on whether it gives the results or it doesn't. And if it gives the results, then you're good. If it doesn't, you get your mark immediately. So we use the university servers. You will be using Linux quite a lot for the submission. Hands up who's used Linux? A few hands. Hands up who's used Mac? Okay, so you've used Linux, you just don't know it. Okay. So we'll be using, I use a Mac at the moment, but that's just for the submission process. So you will need to learn that, and you'll need to set that up. That's part of the first tutorial. So we'll be going through the details of how to, if you're off campus, how to SSH into the VPN so that you can log on, and then you can get into your accounts, and then you can upload and download and do whatever you want. The assessed exercises, you can submit them as often as you like and get a return, so you can see what the results are as often as you like until you've got the score that you want. The only criteria is that the final upload that you do is your marked upload. That's the one that will be marked, and that it's at the right date, so that the timing, so we've got week 3, week 5, week 7, week 9, and week 11. So they need to be uploaded on time. If you're not on time, then there is a scale. You can look on the LMS, I believe. There's a scale showing how much marks you lose over time. So if you're late, you lose marks. That's something to be aware of. So don't be late. And another thing, whilst I'm on it, I may mention this later, maybe in the slides later, but don't leave it until 1 minute before the deadline. Because last year we had this, and not just you, because there's other classes that are doing coding work on the servers and stuff, and everybody was hammering the server to try and upload their work, and obviously the servers fell down. So I was getting thousands of emails going, oh, please help, the server won't take my work in. And it's just not cool for you, because you're going to get into trouble that way. Excuse me. Excuse me, sorry about that. So the final mark that you're going to be having is this, where you're doing a peer review. It's simply, you'll upload your assessed work, your final large project, twice. You'll upload it the first time to be marked on the standard system. The second time you'll upload it will be to a peer review system. The details will be given to you so that you'll know what to do. Essentially, you'll upload the work, and then the day later you'd get the 3 different students. All your work will be randomized and distributed to each other. We will be anonymizing that, and I'll show you what we mean as we get to that point. But you'll be giving anonymized work, and then your job for this assessment is basically to review each other's work. So you'll review, each of you should be able to review 3 students' work. Those 3 students' work that you review, you're then assessed on your ability to review the code. And the reason this is done, in part, is because you get to see that even though I can say this categorically. When you do your work and you submit it, you believe at the time that this is probably the only way and the best way to produce the work. And when you review other people's work, you go, oh my gosh, there's a different way of doing it. And it works just the same. So you'll get to see that. And the details will be given to you in more depth the closer we get to that. But essentially, you will be submitting your work twice. Once, your work will be submitted to me and my team to be marked, and the second will be submitted for your classmates to review and give feedback on. And the quality of your feedback, the professionalism of your feedback, and the depth of your feedback is what you will be marked on, right? So there's no such saying, this is junk, this is poor. You know, you want to say something that's meaningful and useful in that. At this point, any questions? Yes?
Like you just mentioned, like we need to critique our classmates' code. Does it will influence our own mark for the...
That's a very good question. Yes, so the question is that if, will the critiqued review from your peers, from your students, affect your mark? And the answer is no. So the simple answer is no. So your work is marked independently and has nothing to do with the critique. So you'll get your marks as you would normally. The peer review is designed to give you a different sort of angle on how coding works and how to see different versions of the same code. And it's pretty useful as a learning tool. And you'll see when it happens. It'll be different this year to last year. If anyone sat with me last year, which I'm hoping nobody did, because that would have meant you failed twice. And this will be your third time. There was some issues with timing, which we will have fixed this year, so that's fine. Any other questions? Yes. So. Yes. Yes, so you'll be given 3 papers to review, and your review of their work will affect your 5 marks. So it's worth 5 marks. So if you just go like, this is poop, you just say it's complete poop, then we're going to be like, well, that's not a review. That doesn't give any information, right? So we'll be reviewing your review, and that's where you gain those 5 marks. So if you've been professional, you've given good criticism, and it's valid, you'll get your 5 marks. That's the key. Yes? There's no tutorials this week. No, tutorials start next Monday. Yeah. Yes, sir.
So when I submit my code for the assessment,
yes.
Will it judge me on the CPU time memory consumed, or will it just check whether the code is running as intended?
I'm not sure. Can you rephrase the question? I'm not sure.
So say my code is running and it uses some CPU cycles and some amount of memory, and if you believe that it's using more memory than it should.
I see. Okay, yes, so that's a good question. So for the 5 assessed exercises, not at all. No, we wouldn't care at all, even if you write like 1 billion lines of code and it just says hello world in a really complicated way, right? That's fine. But on the larger project, yes, your code style, your ability to express the code, the commenting, and like you say, the computation, whether you're repeating something too often, will be marked, yes. So that will be your sort of final judgment, if you will, to see whether you can code effectively. Yes, sir.
So in the final exam, are we going to be asked to write coding more about
Oh, yes, good question. So in the final exam, will you be coding? The answer is yes. You will be coding. It won't be overly complex, but the problem might be complex. The code that you will be asked to produce will be pretty straightforward, hopefully, by then. There'll be a lot of conceptual theoretical questions, questions on understanding, questions on breaking down code and finding errors. And then there'll also be coding questions as well. So yeah. And it's on paper, right? So this is, it's painful, I know. And I think it's one of the things that we are looking into, which doesn't help you at all, but we're looking into the ability to actually have actual practical examinations on computers. But at the moment, it's just too difficult in terms of the facilities that we have today. So it's still on paper right now. Okay. Obviously, you guys know of LMS, everything we put on LMS as needed. I always do this where I put the lecture slides after the lecture. It allows me to modify the lecture as needed, depending on how I feel that the lectures are going. you don't miss out on anything, so I don't cut anything out and you don't lose out on any part of the lecture by me doing that. It just sometimes I change the way I present something based on the feedback that I'm getting, right? So you all know where the LMS is and the resources, and I'll keep putting stuff on there every week so that it keeps you up to date. That's also where you'll obviously find your labs and such. A quick question on your tutorials. Is everyone scheduled? Hands up who hasn't scheduled onto a tutorial yet. You can do this if you're shy. Keep looking. Everyone's okay. You're all scheduled to go on the tutorials. That's good. I just wanted to make sure that that is the case. Okay, so the subject will need a student representative. Now, I don't expect someone to run down here right now, but if you can either see me, probably send me, look, either come and see me or send me an email with the title student representative if you're interested. Now, the student representative will be sort of a conduit to give anonymous feedback. So if there's anyone who wants to give feedback or discuss something and doesn't want to really sort of raise their neck out and say something, that does happen. By all means, you speak to the student rep, who then will be able to give me the feedback anonymously. Also, the department has like a meeting halfway through or just towards near the end of the semester where the student rep will go and represent yourselves, and then I get feedback based on your feelings towards the class and how we can modify or make it better. It also looks good on your CV, so you can say I was a student rep. So yeah, email me if you want to volunteer. Again, my email was at the beginning of the lecture. But it is quite a serious position in that sense that you do have to be outgoing. I wouldn't expect a hermit who doesn't like speaking to people, who doesn't want to sort of stand up and ask questions or be a focal point to want to do that, because you will need to sort of express yourself a little bit more freely. So just be aware of that. And again, just come and see me at the end. Okay, so I'm dreading this time. So academic misconduct. You guys get it in every lecture that you have, right? So we talk about academic misconduct. And I've always assumed up until this point that everyone understands what academic misconduct is, and that it's just one of those things that we have to comment on. And every year, every semester, every class that I've taught throughout the years, there's been the odd one or two students who have been sort of mischievous, shall we say, and try to get away with some copying of work. Last semester, I had almost like a torrent of students who had, one way or another, used other people's work, whether through them copying someone else's work or somebody copying their work. And it was painful because it meant that I have to, so let's just say that one of you has copied someone's work. We use a system that searches your work. I'll go into the details as I go along, but that will find that and give us a percentage of what's been copied and how it's been copied. I'll explain more in a minute. But I had 20% of the students who had been, the similarity report came above 90% copied. And to say I was disappointed was like an absolute understatement. It was to me, it was like, I was shocked, absolutely shocked. And it doesn't normally happen like that. And I expect none of you, I hope none of you guys are thinking in this manner. And let me explain some of the biggest things that happened. One of the biggest things that people forget, right? We all know, and I hope you know, that when you look at someone else's work and you duplicate that work and you present it as your own, that's copying, right? That's plagiarism. What happened in some situations was that somebody had somehow left their computer open, and somehow, believe me, it's amazing how well someone's memory works when they look at your screen to see what you're up to. Because some students hadn't shared their code, and somehow their code had been copied. And that was the tough one as well, because if you're sharing accommodation, if you leave your laptop open, you don't even know if somebody just walks past with a phone these days, can you really? I mean, somebody could just walk past and record your screen. You know, that was never a thing when I went to uni, but now people can actually copy your code. Now, I don't expect you to do this when you're coding, but I do expect you to be responsible for your own work, and other people seeing your own work, right? It's really painful. It puts an incredible burden on the department, and myself included, particularly on me, because every single person that copied, I have to then put a case for that copy to prove that it is copying and that was work. And then each person has to be interviewed. And nobody wants to do that. I don't want to do that. The student doesn't want to be that student, right? It's just a horrible process. So don't show your code to anyone, your assessed code. So it doesn't, but the thing is, I still, on unassessed work, on all the labs that you're not assessed on, you can have lab parties, right? You can put it on projector and you can discuss it. That's fine, because that's just practice. But on the work that you're assessed on, it has to be yours, and you have to protect it as if it's gold, right? This is your baby, and you're going to protect your baby from being stolen, right? And I expect this, honestly, I really do. We use software that really is advanced in the way that it detects copying and plagiarism. And often people think, oh, I'll copy, if anyone's called Fred, I don't mean you. I'll copy Fred's work. And I'll copy Fred's work, and I'll just change all the variable names. Nobody will know, right? It doesn't work. The system picks it up like that. And somebody will say, I'll copy Fred's work and I'll change all the variable names and the commenting. It doesn't work. The system picks it up. It does. And it's, when you're showing a student somebody who's got all the variable names which are really beautifully thought out, and they're, caring variable names, and then the next student you're showing the same, and you're saying this is the same work. The second student has A, B, C, D, E, F, G as the variable names. It gets picked up. And again, it is painful both ways. If you feel that you need to copy, if you feel that you're struggling to the point that you can't finish the work, I implore you to come and speak to me before you copy. Okay, come and speak to me, and we'll work something out where we can give you that knowledge that you need to get that done. Okay, that's the best I can do. Don't copy. Okay, right, hands up. Who's going to copy? Okay, don't. Yeah, so it's a big deal. I don't want to. I don't want to have what I did last semester this semester. I really don't. And I'll be really annoyed at every single one of you that does. If any of you does copy, I'll be very, very annoyed with you. And I'll yeah. Right. Anyway, okay. So we're going to do a quick poll. This is an anonymous. I don't know if has anyone used quick poll before? Quick poll? No. Okay. So can you see that clearly? Yeah. Go to this website. So if you've got a mobile phone, anything that uses the internet. Go to this website here. So it's basically, quick poll, QP, unimelb.edu.au, and my name, or my sort of initials. So to try and sort of lighten the mood and make things a little bit more sort of feedbacky, we do this quick poll now and again throughout the modules, just to sort of give me a little bit of feedback from yourselves. I can see where you're at, see what you're doing, see what you're thinking. And it's a nice way of just sort of breaking the sort of lecture up a little bit. So it's http://qp.unimelb.edu.au/tchristy, CHRISTY. So this is anonymous, so it doesn't register your IP or anything. It just simply takes your solution. So I'll just hang on. Okay, so that's what you should see, something like this. We'll be doing a new poll. Oh, haha. I turned the internet off so I didn't get any notifications that would cause any problems. Give me a second. Oh my gosh. Come on. Aha. Okay. Okay, so new poll. So don't vote it yet, guys. Don't vote yet. We haven't asked the questions yet. So the idea will be I'll ask some questions, and you get to answer, right? So let's just do a little test, a quick test. How did you get to uni today, right? So, sorry, I'll put that back up in a second. Yep. So there's the question. How did you get to uni today? Foot, choose A. Bicycle, choose B. A car or motorcycle, choose C. I've got a feeling it's going to be D, train, tram or bus, or E, helicopter. Okay. No. It's completely anonymous. There's no personally identifiable information at all maintained, which is a shame at times. Right. Has everyone cast their vote? Okay. So there you are. So let me just get this over here. Yeah, so 101 of you by foot, which is expected. Very few, 11 people by bicycle, which is good on you. Good on you, well done. 4 by car. 43 of you by train, tram or bus. And 35 by helicopter. Okay. Hands up who came by helicopter. I want to be your friend. I'm kidding. All right. Okay, so that's how it'll go. So that's essentially how the quick poll works. And we'll do a real one now. So those of you who did come by helicopter, that's okay. Those of you who didn't, I want you to be very careful and honest about what you answer in the next question. So I want to know how much programming experience you have. So A, you know Java very well. B, you know some Java. C, you know C++ and C, but not Java. D, you know some other programming language. I would imagine most of you guys would probably know Python, maybe. Or E, you don't know any programming at all. So B, this is for me now to understand the status of the class. So it's quite important to me that you are quite honest. Oh my God, I forgot to reset it, guys. So can you all do that one more time? Sorry, one more time. Beg your pardon. I'll give you a few minutes. Right. So how much programming experience do you have? Everyone done? All good? No, nobody. Oh, phew. Okay, let me just get these back in position so we can see what we're doing. Okay, so is 11 students who know Java really well. The majority of you kind of know C++ and not Java, which is a good place to be. Some Java, that's a good place to be as well. Other languages. Now, so we've got the sort of bell curve. Those 11 students who know Java really well, you're not going to learn a great deal in this module. That's the truth of it. We're not going to be doing anything seriously advanced. We're not going to be doing networking. We're not going to be doing databases. We're not going to be doing various sort of advanced Java functionality. So I would advise maybe question whether you're just going for an easy H1, which is fine. I can't say anything about that. If you want a H1, that's what you want to do, that's fine. But ask yourself whether you're going to be bored, because you probably will glaze over if we're just covering the basics, which we will be. When I go into the details in a minute and start going over the basics of what you've got to do, it will be very boring for you. So hopefully, I would reconsider. I'm not sure what you'd want to reconsider doing, but if it's just to get an easy mark, that's fine, and I'm happy to teach you to get that easy mark. But if you already know Java, this probably isn't the course for you. Everyone else, that's fine. Know a little bit of Java is I almost think they're almost like Java. They're almost exactly the same. There's very little in it. I find that, so you might be bored as well, but you'll certainly do really well. Any of the languages you'll learn quite a lot here. If you don't know any programming language, and I recognize that some people came on the course having experience in other fields that were technical. I'm happy if you're willing to work hard to learn the language, and if you've already got that sort of gearing where you're kind of excited to learn. But if you feel even a little bit inconfident in your ability to study hard, I would consider either going on Comp 90059 to get an understanding of the basics of computer programming. I'm not sure if they do ISIS 90088 as well, they're both Python programming languages. Now, I would advocate to consider that if you have a zero programming experience. On saying that, I do believe that you can learn from this, but it will take hard work. It's not like, what generally happens is, in the lecture, you'll be like, oh wow, this is easy. Pfft, easy, I understand what he's saying, that's cool. Then you'll go home, and you'll try and code, and you'll get an error. And you're like, what? I don't know what? Like, and you don't understand why, right? Because it's a certain... It doesn't take a certain type of person. It takes a certain sort of mindset, if you will. You want to be tenacious, somebody who wants to fight to succeed, right? And if you don't know Java, you don't know any language, and you want to fight to succeed, I'm happy to have you in the class, because I like people who want to fight, who want to succeed. That's a good thing. But if you're looking for an easy pass because you think it's an easy class, it ain't going to happen. It does get hard very quick. And you will struggle. So just consider that and consider your options. I think there's a 2-week sort of buffer, isn't there, before and you can change to something else. I don't want to see anyone leave, but if you feel that you can't knuckle down and really get to grips with a new language. The thing to remember as well is that, now, okay, so I can speak just 2 languages, English and Welsh, but I kind of wanted to learn Mandarin, and I struggle. And the reason I struggle is not because I can't say the words and I can't understand what's being said. It's because I don't practice. I have no one to practice with. So I can't seem to learn the language because I'm not practicing. And that's the same with programming languages. It's exactly like learning a real language. If I told you you were going to learn, I don't know, Dutch, you had to learn Dutch, in 2 weeks' time, if you still weren't getting it, you wouldn't be hard on yourself. You'd be like, well, it's a new language. It's going to take time. It's the same with programming, right? But you've got to keep at it over and over again, repetitive, practice, practice, practice. Exactly the same as in a spoken language. It's the same with a computer programming language. So as long as you're willing to persevere and push and work hard and really try and practice continuously, you'll do well. But if you're not, if you think it's going to be easy, you won't do well. And that's just my experience. Yeah, so come and speak to me at the end if you want to, if you want some more information, or if you want to share some more information with me. I'll be happy to talk to you about any of this, whether you're advanced or the opposite of advanced. What's the opposite? Basic? I don't know. Okay. Okay. That's pretty much what I was just saying. There's an introductory to students with some programming experience. So if you've got some, and it's not the language that's the barrier, it's the kind of the concept of the structures. You know, we'll be using loops, we'll be using variables, we'll be using different what we'll call functions in some languages, methods in another. And those constructs you'll be expected to learn pretty quick. And it's those things that you might find difficult if you've not had the experience. Again, if you know Java, you will be bored. I'm happy to sort of discuss more advanced things. My personal programming area of excitement, I guess, is in 3D graphics and 2D graphics, both in Java and C. And I'd be happy to sort of explore those things off the record with anyone who's finding this really boring. But again, it shouldn't hamper your efforts here, because this is what you need to be focusing on. Does that make sense? So if you're really advanced and you're saying, look, I could do with some more advice, I can give you advice and guide you, but it has to be completely separate from what we're teaching. And you have to keep up with the teaching so that you pass. Anyway, we can discuss that further as well. Again, These are the two classes. I'm not sure if this one's been superseded, but this one is definitely running every semester. So if you feel that you can't program at all and you feel that you haven't got that kind of raw excitement to learn, then maybe this would be an easier course to pass. But again, don't sit quietly and just do nothing and just try and push through. Come and speak to me. I'm always happy to speak to anyone and discuss what can and can't be done. So how to succeed in this class? Now, what people think is important. People think you need to be a computer person to be able to program. Now, I had a friend from my previous employment, and he was a computer person. He could do things with Windows that you didn't think were possible. He was really, really smart. He used to run all sorts of weird services for the company, and he was a computer person. He could fix modems and networks and various other things. But he couldn't code for squat. He just couldn't code. He didn't even understand the concept. Because you don't need to be a computer person to program. You kind of need to be someone who's willing to learn a language. And I think that's the emphasis I was doing. Another thing that people think is important is to be good at maths. Now, there are some sort of correlation between people who are very technical minded and being able to learn a language. That's true. But generally, for some reason, computer programmers aren't always very good at maths. I wouldn't class myself as a mathematician. I understand all the maths I would need to do whatever the computer needs to do, and I can certainly put mathematical equations, whether I know how they work or not, into a system. But to say that I was a mathematician would be an absolute overstatement. I'm not. But I do understand the fundamentals of maths for software, maths for computing, and all that kind of thing. You don't have to be good at maths. In fact, the amount of maths that you will need for this course to pass, you probably learned in primary school. As long as you can do the basics, you should be absolutely fine. So there'll be no complexity in that front. Another thing is understanding logic. And whilst having a logical disposition does help, it doesn't matter. As long as you understand what something is and what something isn't, that should be enough for you to proceed. What is important? So those aren't important. What is important, again, is like learning a human language. It's kind of like rewiring your brain. So you all have symbols, depending on whichever language you speak natively, or whichever language you know, how many languages you know. You kind of itemize the symbolic ideology, perhaps, of everything that you say into just noises that your mouth makes, right? And that's pretty much how languages work, and it's kind of the same thing. You can rewire your brain. Your brain will rewire itself so that it becomes good at anything that you practice with. So a key is to be patient. If you find that you're struggling in the first initial sort of learning curve, don't panic. My advice is just practice. Get on your computer and start coding anything, even if it's not part of the tutorials. I always found that finding a project that I enjoyed, something that I was able to do for my own benefit, was always a great way that I enjoyed learning. So if I wanted to make something happen in the computer, then you can do that. You can go off on little tangents where you're learning something that because it's important to you. I would advocate doing that. Yeah, be persistent. Don't give up too quickly, and don't panic at all. But the biggest thing, and I say this for every class I ever teach, is practice. Right? It's not like riding a bike. You can be good at programming. Actually, I would say it's like playing guitar. When I was a young boy. I'm still a young boy, but you know what I mean. When I was young, 17 going on over to about 26, I used to play the guitar every single day, all the time. I used to wake up sometimes holding a guitar. I just loved playing guitar. And then I got married, had kids, and I stopped playing guitar for a long time, about 2 years. And kidding. And then when I play now, I've forgotten so many songs. I kind of know something, and it's just not there. You know, it's not like riding a bike. You get on and you wobble, and then you're off. I find programming is a bit like playing the guitar or playing an instrument. You kind of know that you know it, but you don't know what to do at that time. It comes back, but not very quickly. And the only way to make sure that that doesn't happen is to practice. I think I've probably made that case clear, right? Okay. So things to do next. Do or don't buy the textbook. It's up to you. It is expensive here. I get that. I've always liked to have textbooks. I have quite a few textbooks, hundreds of them actually. I love books, but that's just how I am. Read chapter 1 and 2 for next lecture. If you haven't got the book or don't want to buy the book, that's okay. You don't have to read it. We will be covering everything in detail, but it sometimes brings you up to speed, makes you feel a little bit more confidence in class. Now, I'll go over IDEs, and I'll show you how to sort of compile and run some code. I'll write some really basic code in front of you here. One of my things I want to do is to showcase me coding so that you can see how it's done. Errors or no errors, I'll just run through it. We'll talk about an IDE. The word IDE is an integrated development environment. It's basically kind of like Word, right? It's like the difference between using on a PC Notepad and Word. Notepad doesn't tell you anything. You just type what you want and it's done. Word will say, oh, this is a grammatical error, this is a spelling mistake, and so on and so forth. It's the same thing with an IDE. They're really helpful. I will be using an IDE called NetBeans, which isn't on there. I'll be using an IDE called NetBeans. There are others which I'll explain in a minute. But I will show you how to use, to develop software just using Notepad or any other text editor. You can't use Word because Word doesn't save text as text. It saves it as sort of a bitcode, but I'll go into that with you. And then, so you'll attempt the first workshop on Monday. The servers, Nutmeg and Dimefox, haven't rolled over, so I'm not able to even give you a preview of that. There's a thing where every year they roll over so that it kind of refreshes, puts all the work into an archive, and then allows me to put the new stuff ready for yourselves. That hasn't happened, so I'm just working with systems to get that in place. But that will be done easily this week, way before Monday. So you'll install, there's two things actually, which kind of aren't really covered as in detail on the slides. So Java is a cross-platform application environment. So what it means is that you can run Java on any single machine. You can run it on your Mac, you can run it on your PC, you can run it on the Linux. In fact, I don't know if it's the same with Foxtel. You all know what Foxtel is, right? Because in the UK it's called Sky, and it's the same thing, it's got the same remote. Anyway, so the machine runs on Java. So a lot of things run on Java, but you just don't see it. So Java runs on any platform, and there's two things that you need when you're developing Java applications. The first thing is the Java virtual machine, which is kind of the Java environment where it runs its code, right? That's the first thing. You have to have Java installed on your machine to run a Java program. So when you run a Java program, you're saying, Java virtual machine, run this. And you give it the program, and it runs it. Okay, that's the first thing. The second thing you need to do as developers is you need to have a sort of a compilation program, which is called javac, Java compile. And javac compile turns your words, the English written words or Americanism, sort of words that we have as the language is, turns those into sort of computer language. And I'll show you, I'll actually show you the differences in how that works. So you give it a file that you created, it's a Java file. You compile it, and it gives you back a bitcode file, a file that's kind of converted into executable form that's executed by the Java virtual machine, right? So when you write a Java program, you can't run it. You can't just run that program. It doesn't work like that. You have to compile it first. So part of your first exercise of the workshop will be accessing the servers, installing an IDE, installing Java and the Java programming environment, and trying to run your first program. I'll showcase how to create the program and how to do it in two ways today. I'll showcase how to do it with Notepad and compiling it in the console. If you're on a Windows machine, you'll probably use the command prompt. Hands up who hasn't used the command prompt ever, if you've got a Windows machine. Okay, so I'll show you. And on a Linux machine, you'll use a terminal of sorts. I'll be using a Mac, obviously, and so I'll show you how to do it with a terminal. The similarities are almost, they're very similar, but there's a few commands that you'll need to learn. And once you've got your hang around the basic commands, you'll be fine. So you'll also want to set up a VPN. I can guarantee that by the time you're submitting your assignments, you'll probably be off campus maybe. If you're off campus, you'll need to virtual network in, so you can set up the VPN. It's on the websites that tells you how to make your machine connect to the VPN. So to access the server, you need to be on the VPN first. So you need to log on to the VPN and then log on to the server, which only if you're on the server can you log on to the server, and then submit your work. So that will be the first week's sort of task for you all, so that you can understand how that works, how it's done, and practice that in general. This is going over operating system. So one of the things that Python, Java is good at is working cross-platform. So if I write something on a Mac, I can then run it as well on a PC and on any other machine. The operating system takes care of the things like the DVD drives, the mice, keyboards, display screens and stuff. So it deals with that, and all you do is use the standard commands that you have to access those things. So the program controls all those things for you. A note to remember is that the operating system controls the resources, and it allocates time, like a time-sharing program, between everything that's running and your application. So this is something to be aware of, depending on what you're creating, is that you don't have control over the computer as directly as you think. You have control over what commands you're offering to the operating system, and the operating system decides on the time of when that's run. It's usually immediate, but there can be times when it's not as immediate as you want it to be. You'll be used to using your operating system like Windows or iOS or wherever. It's not iOS, it's called OS X on a Mac, or some other Ubuntu or Unix type of WYSIWYG, what you see is what you get operating systems. You will need to get, oh, by the way, all of those have a shell structure. I'll show you what that is now, in fact. So a shell structure is basically a text-based control portal that allows you to control everything that you're doing using sort of commands, as it were. It's less friendly, but more powerful, right? So if you've got a Mac, you can just start typing in terminal, and it will open up a terminal. This is my terminal. Anyone recognize that I like the Matrix? This is completely, yours will look different, so I've probably got more information. So mine just says my name and some information about the system that I'm working on. But essentially, you've got this little square here, which allows you to type, right? And you'll type in commands there. So what I'm going to do, I'm going to change the directory. Change directory. Oh, hang on, let me get my keyboard light up. Can't see anything. Change the directory to a Java file. I think I've got one there waiting. And I'm going to type list ls is going to allow me to show you what's in that folder. So the Java, is it big enough on there? It is, isn't it? Yeah. So this Java is the folder that I'm in, right? So that's all that means. I'm typing ls. Now, if you're on a Windows machine, let me show you something else actually before I do that. No, I will do it. Sorry. ls will just show you what's in the directory, and you can see it's just repeated nothing. So that directory is empty. If you're on a Windows machine, you type in command or cmd, both will work, and it will open up a terminal, usually black and white. So you can do that now. And you can type in dir, which will give you the same as ls. So this is using a Linux-based kernel. So the background of this is Linux. So anyone on a Mac will be using the same as me, but we'll have different words there. Anyone on a PC will be using command prompt, which is exactly the same sort of thing, same sort of environment. But what I want to show you is, the first thing is you want to know whether Java is installed on your machine. And the way to do that, just to see if it's done, is just type in Java. Oh, my God. If you type in Java and press Enter, if it says it can't find anything, it means you don't have it installed correctly. Doesn't mean you don't have it, it means you don't have it installed correctly for what you need. So if I type in Java, it gives me a huge list of commands. That means I have Java installed. That's the first thing. The second thing is to type in javac, right? So that's javac, J-A-V-A-C, Java compile. If you type in javac compile and you get an error saying it can't find it, you don't have the Java compiler installed correctly. But if you get this kind of thing, more nifty, lots of garbage, that doesn't mean anything to you right now. That means you have Java installed correctly. Now, I'm pretty sure, but I can't be 100% sure. I don't think I've installed jav1 or Java on my Mac. I say that loosely because I can't remember if I did or not. If I didn't, it would... can somebody on their Mac test what I've just done and tell me that you've got it or you haven't? Okay, anyone with a Mac, hands up if you have got jav1 on your machine. Okay, did you install it? You're not sure? No. Okay, so this is inherent of I guess, of Mac. Mac also has OpenGL built in and stuff. But on a PC, standard Windows PC, it generally isn't installed. And I know this because I remember when I was learning Java and having to install the environment variables, I was a bit of a pain in the bum, to be honest. But you will have to set up both your Java compiler and your Java runtime environment to run on your command prompt. There will be instructions on how to do that, and that will be part of next week's sort of activity to make sure that you're up and running. I'll just jump out of this for now, come back to here, because so that was just basically showing whether you've got Java and jav1 installed, okay? This is just going through different commonly used operating systems which aren't. We've kind of covered this already. Just to reiterate, with your tutorials, your workshops, most of you, or half of you, might have been allocated bring your own devices, I think. It's something that we're trying to push. Now, as I said before, I really think it's a good idea to get your own device set up. It just gives you so much more freedom, and it empowers you to do so much more work. So setting this up on your own device will be very important. Two things that you will struggle maybe with is the Java compiler, because you do have to go into the Windows variable settings, environmental variables, which means that you do have to have admin rights. And the second thing is just eluded me because I thought I heard someone fart at the back, but I think it was a chair. Sorry. Oh, the VPN. The VPN can also be a headache. When I connect to the VPN, I have to do two things. First of all, I open up a terminal and I connect to the VPN. It then looks like it's hanging, like it's just staying there and doing nothing, but it's not. It's actually connected to the VPN. The second thing I have to do is to run another terminal, a second window, where then everything I do on that is part of the VPN. So I have to have two windows open, which is it feels unusual, but that's how it works. So again, that will be part of what you'll be dealing with. And you will need to get comfortable with some basic, very basic shell script in Linux or Unix, because we will be using that. It's all there for you scripted so that you just follow the script and you should be fine. But that will be your initial task, to get your environment set up so that we can be free to do what we want to do. In the labs, you'll be using Windows. If you're using your own device, obviously you'll be using whatever device you have. The servers and Java all work independently on any system, so you're good to go. So it's a good language to obviously learn on. The key is that you must use the Linux shell or Unix shell to submit your work. So if you can't log on to the server, to either Nutmeg or Dying Fox, they're both the same storage, so it doesn't matter which one you connect to, they're both exactly the same. If you can't log on to that, then you can't submit your work. If you can't submit your work, we can't mark your work. So that's important that you do get that set up in the first instance. And that's pretty much everything that needs to be said. So we'll have a quick break. I've got 5 minutes and we'll reconvene. Any questions before we do, by the way? I should have asked. Sorry? Right. It is Linux, yeah, it's the same. Yeah. I'll run through that again. In fact, ask me that again when we kick back on. Yeah. Hey buddy, how you doing?
Yeah, not bad. Well, I didn't have them, but yeah.
Oh, really?
Well, I just worked through it. Technically, yeah,
I guess with all the exams, so yeah.
yeah.
Any most of it work?
Majority, well, yeah, there's a small few different didn't do so well, but yeah, it's yeah, good. Yeah.
Yeah.
Yes,
No, it's good. It's good. That's most of the break. I worked with a couple of different instruments actually. I kind of built a program for 3 or 4 weeks. So we're pretty keen on that. That's why I kind of kept it.
Yeah, by all means, yeah.
Because I'm interested in the finance side, so then I'm able to get analyst status.
Oh, okay. Yeah. It's good to have that kind of sort of ambition to do something with it.
Yeah.
That's the cool thing. So
It's really fun to
it is.
otherwise.
And I think when you just want to pass, just for the sake of having marks, it's kind of like,
It's definitely best.
it's okay. Let me make sure this is on mute.
I was just going to say, I'll be keen to do that.
Oh, okay. Yeah. Well, I'll
Do you want me to send you an email?
send me an email. Yeah. I'll consider it. That's fantastic. Excellent. Thank you. Appreciate that. I hope you say it. I would. I don't think you look at yourself. Yeah.
Thanks for that.
No worries. Yeah. Yeah, 5 9. Oh, then how just I don't have for you to decide, right? But I would say, look, you can try next week, see what we get. I'll give you 2 weeks to make a transition. But try next week, see what we get. If you're struggling, then we can discuss that. Yeah. No worries. You're welcome.
Hello.
Can I see your student reply?
Sure. Why not?
I should apply through email.
Send me an email. What's your name? So that I don't. I'll just write it on here. If you
Yeah.
write your name there,
Yeah.
and
Right here.
yes, and I'll keep that in my bag, and I'll just double check. But send me an email as well.
Oh, okay.
And I'll look out for your name. Okay. See you, man. Okay.
Yeah.
Awesome. Awesome. Thank you. Yeah. Thank you. Welcome aboard.
Thank you.
Thank you. Too easy. Okay. Hopefully everyone's had a break. Right, shall we continue? You can hear me, right? Okay, guys. So, as per every language that you learn, it's customary to learn how to create a program called Hello World. Hello World is just a program that displays the words Hello World back to you when it's run. And this class will be no different. Maybe I'll change it just to hello, maybe students. So what you're seeing here in front of you is a very basic and primitive Java class file, Java program. So what we see here is the kind of expectation of the most simple program that you will see. A lot of it is what we call boilerplate. Some of the things you have to do, it's the overhead, if you will, of Java. And those things are simply like this word here, public class. These are a necessity. And this, for every single project that you create, independent project, you will always have to have something called the main method. So this text that you see here, public, static, void, main, string, args, you'll find it somewhere once in every program, project, yeah. I'm trying to get the language right. Every project that you create will always have to have a main for it to be executable. If it doesn't have a main, then you can't run it. So the main method is how the application starts, okay? So for now, I won't go into the details of what all these things mean, but just accept that that's the kind of structure that every single program you create will need to have once within its structure, right? So it's just a given. I'll show you how to do that in both Word type environment, and I'll show you how to do it in an IDE, and you'll see the difference, that one of them is very easy, one of them is still easy, but less straightforward. So just look at it as boilerplate, and all will be explained. So a program is made up of a file, which we call in Java a class. Each program is actually, a program is a combination of one or more classes. So you can have thousands of classes, and often will have thousands of classes, inside one project. Within that project, you will have only one main method that starts the program running. So the class is highlighted in green here. So you've got this class is everything in there in green. In Java, for those of you who have done Python or C or any other language, a function in Java is called a method. So sometimes I'll accidentally say function, but I mean method, because in Java that's what it's called. It's called a method. It is exactly the same thing as a function. It does the same thing. It acts in the same way, but it's called a method. So when I use the word method, I mean function, if you know what function means. If you don't know what function means, then I just mean method. And you'll learn what a method is, right? So your class is essentially a file that is, it starts with a curly brace and it finishes with a curly brace. And in between that curly brace lies your program, right? So your class encapsulates or holds in the program within curly braces, open and closed curly braces. Each method also starts with a certain boilerplate. I'll go into that in detail in the next lecture. But it has some way of describing what the method or function is called, any arguments that it requires, and that too. So each method is also encapsulated by open and curly braces, right? In Python, you don't have braces at all. You just have tabs or spacing, line spacing, right? In Java doesn't care about line spacing. You could, in fact, write this code all on one line, and Java would be happy. It would look ugly, and nobody else would be happy. But Java would still run it, because it's looking for the braces, it's looking for the brackets. That puts it at maybe a partial disadvantage in terms of code quality over the broad programming styles of everyone. But what we do here, and what we will be doing here, is trying to teach you the expectations of what is expected in a professional environment and how to code and the structure and style that is expected of you. It's pretty straightforward, but it's also what's considered a normal to do it. But it will not break your program if you don't do it. So if you want to be crazy and do something really wacky, then that's entirely up to you. But just don't submit it for marking. I expect to have everything in the way that is normal in terms of the industry. So most people use an integrated development environment, and I'll refer to this as an IDE. So I'll always talk about an IDE. If you've already used an IDE, that already has Java implemented into it, by all means continue to use that IDE. That's okay. If you've done this before and you're happy with what you'll use, that's okay. The two that are often used are in Java are Eclipse and NetBeans. When I first began, I started on Notepad, then moved on to JEdit, started using Eclipse, loved it, it was great. And then eventually NetBeans became more advanced, and then I now use NetBeans, and NetBeans is a brilliant environment. And both are free, so Eclipse and NetBeans are both free, so if anyone tries to charge you for downloading them, then you're on the wrong site. So Eclipse and NetBeans are both IDEs that we will be advocating. I will be using here in class NetBeans, so I will always use NetBeans as part of the environment. For today, and probably today alone, maybe, I will use also the terminal to show you some basic constructs of what's happening. Because one of the things about using an IDE is, yes, it gives you information, that it finds commands for you, it automatically fills in these special terms called imports or includes in different languages. It does these for you, but it also hides a lot of complexity, and it tries to keep order in its own way. But it kind of takes away your understanding. And I want you to understand what is happening with the code. So what I'm going to do, I'm going to just fire up now, and you're welcome to join along. If you've got jav1 and Java installed, you're welcome to join along. Obviously review this lecture, and make sure I'm not muted here. No, we're good. You can review this lecture and do it yourself at home once you have the environment set up in your own leisure. So what I'm going to do is I'm going to launch terminal, so just type in terminal. If you're using a Windows machine, I might change the colors just for your benefit. Okay, so if you're using Windows, you would type in command instead of terminal. So you would do this, and you would type in command, not command like that, and it should open the command prompt, or CMD, and it should open the command prompt. Now, I'm using a Mac, so I use terminal. Terminal is part of Unix or Linux. It's a Linux-based machine. So Apple took the free open source operating system of Linux and built its own front end on top. I do like Apple now. I used to hate Apple, I'll be honest. But I got a job with IBM, funnily enough, and they were working on Apple, and I started using this machine, and I wanted to throw it out the window for a while. But once you get used to the secrets and all the little things, it's actually a great machine, so I'm very happy with it. Okay, so if you've got Java and jav1, you can follow along. If not, you can't, and you can do it later. That's the main point. So I'm going to use a really basic editor called Nano. Okay, if you've got Notepad, you can type in the word Notepad, the same. So you would type in Notepad here, and I'm just going to create a file called hello.java. That's going to generate a new file. Before I do that, let me get rid of this to show you something. So I'm going to do ls, and you can see there's nothing, there's no files in here. So this folder is empty, okay? So I'll do nano, I'm just going to call it hello. You can call it anything you want, and I'll show you what the expectations are in a minute. I'm creating a file called hello.java. Now this is a text-based file. You can't use Word, you can't use any text editor that uses bitcode to store the payload. Excuse me a second. Excuse me, I beg your pardon. Okay, so when I do this now, it's going to have this ugly looking screen. This is now a text editor that's opened in full screen. If you wanted to use Notepad, you can follow along in Notepad. Even if you don't have Java or jav1 installed, you can still follow along with the code. You just might not be able to compile right now. So the first thing we do is these boilerplate things. You have to type in the name, public, class. So this is saying to Java, I want this to be a class, right? The next thing I do is really, really important. And as a newbie, somebody just starting out, you may make this mistake quite often. The name of this file here, hello, I have to write that exactly as my class. So if it's capital H, it has to be capital H. If it's whatever that word is, whatever the file is called, this class has to be called exactly the same name. If you don't, you will get an error when you compile, okay? So the first thing I'm going to do is open brackets, a couple of lines down, close brackets. So in between these brackets, I will write my code. So now I've just created a class called hello, and the next thing to do is to write the class. Now, as I mentioned before, every single project that you have must have one main method. In other words, it needs to have a block of code that's called main. Now, public static void main, get used to this as just like a stamp. You don't have to understand it today. We will understand it by the end of the module, at the end of this course. But you'll write this once in every program. Public static void main, string. You can either put args like this. I'll do it like that. So I'll say nothing more about it for now. I'll explain more later. Okay, so what I have now, as you can see, between this bracket and this bracket, I've got a class, and between this bracket and this bracket, I have a method. So far, so good? Pretty easy going, right? The only thing that you have to take on face value is that this method name is just the way it is, right? It doesn't change, it's always that. Pay particular attention to the capitalization of the S, and also the same, this has to be the same case. So if this is capitalized, which it should be, that also has to be capitalized on the H, right? So those are the basics. And then the next thing to do is to type in your code. So whatever I write inside these two curly brackets in this main method will be what will be executed when I run the program. So in this case, again, just take this as boilerplate, just expected. So we're going to use something called system dot out dot print line, and then whatever message you want. So I'm just going to say hello students. Okay. So far so good. So all really I'm looking at here, I will mention the semicolon in a minute. I'm leaving it hanging for now. So what I'm simply saying is I have a class which I'm calling hello, right? That's what it's called. In that class, I have a method which is called main. When I run the class, Java looks for main, and whatever's inside main, it executes. In this case, it's executing a command called println. That's an L, not an I, not a 1, ln. And println simply says, print a line, and at the end, go down to the next line. So we're printing a line. If you didn't want it to go down to the next line, you just type in the word print, right? But you'd still require system dot out dot, I'll explain more about those later, and println. And then so this program is simply going to do, or is simply going to output that. So hello, comma, students. Let's put in a, oops, not one of those. Put one of those there. And one of the things you will guaranteed 100% do all the time is you will forget that Java requires a stop at the end called a semicolon. So that's a semicolon, as such. Okay. And the semicolon simply says that this command or this what I'm trying to show you is now finished. Move on to the next command. Okay. So far, so good. Any questions at this point? Everyone happy? I can see you. Okay. I think I can see you. If I can't see you, yes, yes. Sorry, who is that? Oh. No. Yes and no, but no. Mostly no. In Python, you use it to sort of indicate that you're going into, in this case, a bracketed section, right? So, you say, I'm going into the body of a loop or a body of a function. In Java, that isn't the case. In fact, if I put, for example, if I put a semicolon here, it would simply terminate that actual function or that class, and it wouldn't run it. It wouldn't associate everything underneath it as being part of it. So it's kind of the opposite in that sense. Does that make sense? Yeah. Okay. Oh, sorry, yes. Go on. Sorry, let me come over. Oh, the void? I will explain that later. I don't want to confuse
just remember that you must always have public, static, void, main. Just remember those words, and it's always in that order. I'll explain more as we go along, because we do explain more in detail. Yes, is that okay? Yeah. I just wanted you guys to get sockets.
Don't worry. I had to use the socket on the back wall because there's only one socket here. Anyway, don't worry. Okay, so now we've got our, this is a complete application now. In theory, there are no mistakes. Maybe there are. We'll find out. So I'm going to exit this. On a Mac, you hold down a CTRL, press X. I'm going to press Y to say yes. I'm going to press Enter to do the program. It brings me back to the command prompt. So all I've done is I've saved and exited. Okay. So now when I type in ls, or if you're on a Windows machine, type in dir, it's going to show we have this program, this application, or this file called hello.java. Hello.java was exactly what we wrote. It's just a text file with exactly what I wrote a few minutes ago. So far, so good? Yeah? No? Okay, so were you following along? Okay, so what I did, if you're still in there, what I did is I hold down CTRL and press X, and then press Y to say yes, you want to save, and then press Enter. It's really, yeah, it's very primitive, right? It's just that's how Nano works. It's very primitive. But if you're using Notepad or anything else, just save. You don't have to exit, but you just need to save. In this particular instance, we need to exit just because of how it works. Excuse me a second. Excuse me. Okay, so now you can see that I created a file called hello. The next thing to do is to compile the file. Now, Java is really primitive in this sense as well. So we're going to use the javac command. So we're going to run a program called javac, and we're going to provide that file name to javac. So is there a question? Oh, okay. So I'm going to type in hello. So you have whatever you call the file name. You need to say the same thing. So now I've done javac hello Java. Now, if there's an error, it will give me the error. What it's going to do is going to try and take that file, compile it, turn it into computer language, if you will, bitcode, and if everything's fine, it will say nothing. It will just go, good on you, you've done it. So let's hope. I might get an error, I might not. So I've got no error, so that means mine was fine. Now, if I type in ls or dir if you're on a Windows machine, you can see that there's now, oh, hang on, what did I do? There you go. You can see there's a file called hello class. I didn't create that. Javac created that, right? And so there's my original file, and this is my hello class file. So what I'm going to do, I'm going to do nano hello.java to show you that that's the code I wrote. I've just reopened the file, and you can see that's what I wrote. I'm going to do Control and X to exit. I didn't change it, so it doesn't ask to save. And now I'm going to do the same thing, nano hello dot class, right? And this is what you see, garbage, okay? Because that's now converted into bitcode or bytecode so that the Java virtual machine understands it, right? So it's compiled. So that's what you run. So when you run a Java file, it's this bitcode, bytecode that you're running. Does it make sense? Okay. So what have I done so far? I've created a file called hello.java. I've told you just to remember that these words, these public class and public static void main, just accept those for now, and I will explain everything and exactly how they work and why they work and stuff later on. But for now, just recognize that that's just boilerplate. That's what you have to do. I've asked it to print out the words, whatever it was, hello students, and I've saved the file. I've then compiled the file with javac, right? Everyone with me on that? So the next thing is to run the file, right? So Java has this thing called the standard out. So when I ask it to print something to the system.out, it prints it to the whatever I'm working on. So if I'm in an IDE, it'll print it to the output of the IDE. If I'm in a command prompt or a terminal or something similar, it'll print it out to the terminal. So to do it, you simply type in Java. So you're going to tell Java, I want you to run this class. You type in the name of the class, remembering it's capitaled if it's exact casing, right? But this time you don't put the word .class. You simply put in the word hello in this case. And when I run it, I expect to see the words hello student. So this is the output. So that's showing me that it's ran the program. Make sense? So far so good? Just put this on so I can actually see. Woof. Yes. Okay, sorry guys. Just waking you all up. Okay, any questions on that for now? No questions? No? All good? Okay, I'll do the same thing now. So what I'll do is I'll go to my IDE and I'll show you how to create one in an IDE. Okay? So this is an IDE called NetBeans. You may have a similar one called Eclipse or anything else. If you haven't got this now, don't worry, but I'm just going to show you the differences and how it's easy. So in an IDE, you have to create a project. I'm just going to call it's a Java application. Click next. I'm going to call the application comp 900, what is it, 41, and I'm going to do semester 2, S2. It's a horrible name, I know. That's what the application is called. And you can see it's already generated tons of code without me doing anything, right? So it's created this, which is called a header. It's created what are called Java documentation code for each element within there, and it's then given me the public static void main. And one of the biggest things it's doing is highlighting the code in different colors so that I know what the code does, right? So to make it simpler, what I'm going to do is I'm going to just delete the stuff that we don't need. I'm going to get rid of these stuff. I'll explain more in a second, so that it looks very similar. In fact, I'll get rid of that as well to show you an easy way of doing it. This part here, I'm going to leave that there for now. It is ugly, but I'll explain packages later. That's something not to worry about for now. In fact, what are we looking at? It's here. No, we'll leave it there for now. So, in an IDE, it does the code for you. But if you were to also type in what are called shortcut commands, so if I type in public p static s ps static void main psvm and press tab, it automatically fills the code. Because you repeat these things, you do them again and again and again. So it just gives you a quick way of doing the code. And in the previous example, I used system.out.println, right? So we just type in SOUT, system.out, and tab, and all of a sudden print line's there, you see? Again, this is how an IDE makes things faster, easier, and quicker. It makes it so much more productive. And you can type in anything you want here. Hello, world. What I'm going to do as well is I'm going to right-click or double click on the name, and I'm going to set this as my main project. So now this is set as my main project. And built into the IDE, we have the Java compiler. So Java's built in. So now that I've set it as my main project by right-clicking and choosing set as main project, it's unset now, but I've unset it. Oh dear Lord. Set as main project. Now all I have to do to compile and run the program is to click play. And there's hello world down in the command prompt here. Is that big enough? Yeah. Right? So what I've done is I've shown you two examples. One, the basics, saying that we have a Java file that we create and we code and put the code in. We save it, and then we compile it. It creates a new file, which is a Java bytecode file, bitcode, I forget which way that is, a bitcode file, which is all scrambled words, and then we use Java to run that file. We've done the same thing in the IDE, but in this instance, it's kind of done it really easily for us. It's just helped, right? It made it so much faster. Oh, I thought it was a ghost. So I will be using the IDE, obviously, because if you don't want to use it, I understand why, right? If you don't want to use an IDE, it's because you really want to learn, really want to learn, right? The fundamentals of Java programming, and that's perfectly fine. And in fact, it does help because if I show you something, let me go and show you what I'm going to do. I'm going to go back into the hello.java file, right? And I'm just going to take away one. I'm going to make an error basically, and the error I'm going to do is a very simple error that you all will do, I'm sure. And if you don't, good on you, because I know I did plenty of times. I'm going to take away the semicolon. Right? that basically breaks the compiler. It says, I can't do it because you've forgotten something. You haven't ended that line. I'm still waiting. So I'm going to control an X. I'm going to say yes and save. And this time I'm going to do jav1 hello.java. And this time it gives me an error. It says error, semicolon expected. And it's telling me that it's in line 5. Yeah? And it's giving me the line, it's showing me, and it's even putting an arrow there to say, look, I expect a semicolon there. Now, in my mind, I'm thinking, why couldn't you just put one there? You knew where it was, you knew where it was supposed to be. Why couldn't you put one there? Well, compilers don't do that. They don't presume you don't know what you're doing. They don't presume that what you want is what you want. Instead, they just tell you that this is the error. So now there's an error there, and you can say that that's what's happened. And if I go to the IDE and do exactly the same error, and we run that, we should get exactly, oh my God. Okay, the reason that's, there you go. So if I clean and build, come on. There you go. So it's giving me an error, a little bit more convoluted, a little bit more information there, but the error is still the same thing. Error, semicolon, expected. And this time it doesn't tell me where it is, it doesn't give me the arrow pointing where it is, so it's kind of less information. Okay, so just to recap, the differences that we see, the differences that you're seeing between the IDE and the text editor may seem superficial, but the differences that's happening underneath. If I was to show you the file structure, I don't know if I can see it here. Is it fine? Where is it? Okay, I was trying to think of where the file was. So if I was to show you the folder that's created to create this file inside the IDE, it'll create a package file, it'll create source file, bin libraries, and it kind of gives you this infrastructure that you don't create yourself. It creates it for you. You get used to it, and you will use it, and you'll be happy to use it. But in the first instance, just to understand how things work, you want to know what's happening, what the compiler is doing. And that's why if you do use Notepad or something similar, and you use Java to compile, good on you. It really is, it's a strong way of coding, and it's showing that you have some kind of thirst for knowledge and for also a beating. So I've just fixed that now. I'll go fix the other one. So what was it, nano? There you go, I'll fix this one. I don't know if I can do that. Okay. There you go, save that, control, exit, save, yes, there you are. So we'll just compile that, and now it runs it again, and that's fine. And that's running fine. Okay, so those two examples. Go back to the slides. So you can use anything you want to write your code, as I've just given some examples. I would advocate using NetBeans only because I'm going to be using it in class, and it might be easier for you to follow along. But use anything that you're comfortable with, that's okay. IDEs do hide some of the boring detail and do make things very quick to develop. I'll also show you later on how it generates code for you, so you don't even have to code. But the downside to that is that when it comes to your exam, you don't have the IDE, right? So if you've constantly been using the IDE to do things really quickly, I can't mark your work if you just put in SOUT tab. Do you know what I mean? I'll know what you mean, but I can't give you the marks. You're going to have to put in system.out.println brackets and such. So for now, I won't go through too much of the coding shortcuts because I want you to learn the basics. But hopefully you have a good understanding of that difference in structure. Any questions? No questions? Okay, so this is just going over what I've just shown you. So just remember that you're creating a file called a Java file, which is your text. Then the Java compiler is creating a compiled version, which is the class file. So it's creating exactly, it uses the same name that you produce. And you're producing yours with the word Java, the file type is Java. The Java compiler changes that to class and changes it to bytecode. And then the Java runtime environment, the Java virtual machine, runs the code for you. And that's pretty much the basics of a Java application, right? So you'll be using this again and again and again as we go along. We looked at system.out. There are three different types of data information structures. So you have the standard output, which in this old one here, like a million years ago, I don't know how long that would have been, that was the output for a typewriter, right? So you type and the output would come on paper. About 40 years ago, 35, 40 years ago, this would have been a standard output for a computer, and that's what you'd see. So when you're running a command prompt, the standard output will be back to the command prompt. When you're running your IDE, the standard output will be to the IDE's output, right? We won't be covering graphical user interfaces here in this class. I can give you the pointers on how, on what to look at and how to run those if you need to. We won't be doing graphics here either. But again, those are just outputs that are different. So you have different outputs. You have to specify the output in those instances. So when you're doing a standard output, it goes back to the calling command structure. So that essentially for us, it'll be the console or the output of the IDE. Excuse me. So this is just reviewing what I've just shown you in practice. Again, you'll have your own username or whatever you have as your path structure here. And this is basically, you use jav1. Once you've done your code, you use jav1 to compile it. You use java to run it. You drop the .class. It's running the class file. It's not running the Java file. So you have two files, Java file and class file. It runs the class file. Okay. So if somebody asks you to send them the source code, assuming it's not assessed, you send them the Java file. Because if you send them the class file, you're sending them scrambled information. They won't be able to read it. Again, just recapping, when you've used the compile jav1, if there's an error in your code, it will tell you the error. I think it's a good learning practice to try a few times running it in the command prompt so that you can see what the error is. Read the error. Don't just ignore it and look for the error. Read the error. Work out what it's trying to tell you. It usually gives you a line number. It also gives you what's called an error stack trace, which we will cover later on. But it'll give you an error, and usually you'll find the one error that is often responsible for all the errors that you see. But we'll come to that later. So code is made up of two parts. You've got the code and the data. In this example, it's saying that code is a little bit like verbs, or the doing things on the data is a little bit like the nouns, the actual things. So each data has a single sort of type. Java is very specific with its data types. Now, Python isn't, so if you've come from the Python stream to this class, Python is really simplistic in the sense that it allows you to say a variable is anything. A variable is a, what's the word? A variable, as you should know, and if you don't know, is basically a name that we give to a memory location that we can call upon and modify time and time again, right? I often simplify and say it's like having a pocket. You need to know which pocket it is, so you give the pocket, the variable name, a name. But in Java, you have to give it a type. Now, what is a type? A type means the type of data that you're going to be providing. So each datum, each single part of the data, each variable that you specify in Java, you have to give it, you have to tell it, you will always be responsible for this type. Then that variable becomes locked as a certain type. You can change them and stuff later, but you have to specify the type. So there are three kinds of types: primitives, which we'll cover today, classes, and arrays. And there's others as well, but we'll cover those as we come along. So here are the primitive types. Now, I will expect you to know the types, these types, by heart, right? But I don't expect you to understand the values. So you won't be, I won't say to you, how many values are in a short in an exam? I mean, I wouldn't expect you to know that. So you don't have to memorize the types in terms of their values, but you do have to memorize what they do. So we have a Boolean, it's the most basic of primitive types. These are primitive types, okay? I'll come over to what I call class types, or like the string is a class type. We'll come into that later. So a primitive type, Boolean, simply means true or false. The word true, the word false, in lowercase like this. essentially you use Booleans to tell whether some condition is met or some condition is not met. Something is true or something is not. It uses 1 byte, so it's very, very small space. Java doesn't do bits. So Java, you still have a byte. We won't be going into bits and bytes, but if you do understand them, Java doesn't do bits. It simply is the smallest component it has is bytes. You can work with bits, but you have to develop your own code for that. A char is a single symbol, character symbol. So when you've got a string like the word hello, the H is a single char, a single character. And a char holds 2 bytes and holds basically the Unicode of all the characters that you need. Now, for various reasons, most Java environments are limited to the Unicode character symbols that it has. I know there are in excess of 4 billion or something different Unicode characters available to us in the world, but Java's locked down to a very, very small amount that you can play with in future labs. A byte is just that, a single byte, and it has a value of 2 to the power of 7. Something to be aware of here is that a byte, for example, goes from negative 128 to positive 127, right? So it's not balanced. Can anyone guess why? 0. Well done. Yes, the 0. So it has to account for the 0. So that's why one. I don't know why they chose to go negative more than positive 1. That's for them to decide, I guess. But it's not for them to decide. It actually works with binary and the way it works. The thing is, if you exceed, so if you cast or if you set a variable as a byte, if you use the word byte, I'll show you how to do it in a minute. I'll keep an eye on. Oh, okay. Well, maybe I'll show you next week. If you use a byte and then you set a variable name to a byte and then you exceed the value that the byte can hold, essentially the byte can't hold anything more than itself. And what happens is it will go back to the bottom. So it's almost like if it gets to 127, if you add 1 to 127 in the byte form, it'll go to minus 128. So it works, it sort of trips over and works in binary, right? You have short. A short, again, has just a different value. So you can see that the values are just, they have intrinsic ranges. So they go from negative something to positive something. And that is their sort of limit, right? Naturally, you can, and there are these things called methods in the library in Java that you can use. We won't be using them in this class that can exceed these values and increase these values for what you want to do. But these are the basics. You have an int, which is again just a standard number from minus 2 to 31 to plus 2 to 31 minus 0. Minus 1. The minus 1 again is to cater for the 0. A long, again, it just gets bigger, but the differences are you can see the amount of bytes they use. A float uses 4 bytes, goes to a certain value times 10 to the 38. But I would advocate, look, if you're going to use a float and you're making a small program, just use a double. And that way you're not sort of rodding your own back. You're not beating yourself up with a float that could be limited to the amount of information it can hold. So generally, in this class, we will use booleans, chars, ints, and floats, generally, right? The times you will use the other ones, the other primitive types, will be when you're trying to either save space, because you're using billions of data sets, or if you're trying to save some element within the computer structure, whether it be space or speed, right? But for everything we're going to be doing, boolean, char, float, and double. Now, a quick poll. Do you remember the quick poll? HTTP. What was it? / quickpoll.unimeld. I think we're probably going to run out of time actually, but we'll just do this last one and then we'll probably call it then. So it's quick poll. Quick poll unimeld.edu. Before you do anything, don't make any decisions yet. What am I doing? Let me reset. Nope. Okay, so there's a new poll ready to go. Which one of these is not a primitive? That's the question. Which one of these is not a primitive type? Do you remember? Got a conferring? Right, let's have a look. What did we say? I'm going to update it. Okay, most of you thought bool. Can anyone tell me why you think that? Okay. The reason bool is correct is because in Java it's Boolean. Right? So in other languages it's bool, but for Java they wanted to be more verbose and they decided that it would be Boolean. So if you've done other languages, you'll be forgiven for using the word bool because it means the same thing to you. It's a symbol that you recognize as true or false. But in Java, it's Boolean. Okay, so that's like a trick question. In the exam, I like to do trick questions in the quick poll, but I won't be doing it in an exam. I won't be tricking you with such things in an exam in that case. We've got a few more minutes. I will keep going just for a few more minutes. Oh my gosh. Just so that we can cover a few of the little things. So, in Java, like any other language, you've obviously mostly done languages before, you have variable names. A variable name is basically a name you give to something that you want to store in memory, right? So you give it a name, and that variable can hold different values, different variable types or value at different times. In Java, it's customary that variable names start with a lowercase letter, never with an underscore, never with a number, never with a capital. Capital letters are reserved for class names. That's how we can discriminate between classes and methods and variables. So we have all variables will always start with a lowercase, and then you then concatenate or stick together the name of the variable based on what it does. So if it feeds the cat, it would be feed cat, small f, capital C, right? So in this example here, you have height, or then you have window height. You can see that height, the variable for height, is small h, but here the variable for height is large h, or capitalized H, and that is because we use a system called camel case. So small letter to start with, every other word within there, just like if you were doing a hashtag in Twitter or something, you add a capital letter per each new word. You make these, so when you're making variables, you have to think about a name that sort of represents what the variable is used for. And you don't want it to get too big, though. You don't want to have, like in Wales, there's a train station. I don't know if anyone knows this, but there's a train station that is a concatenation of a lot of words. In fact, I will... I'm going to show you the train station's name. Here it is. Oh dear, come on, picture. So this is the train station name. I don't want to see things like this in your code, okay? I live next to this, by the way. This is we call it PG for short, but it's which is kind of a mouthful. You can do that in Java, but I don't want to see that. I want to see very succinct, unified variable names that mean something but aren't as big as this train station. So best practice is to make all variable names descriptive, not too long. You can use clear abbreviations, so you can abbreviate things if they're very clear, such as SRC for source, etc. We'll go into that in more detail later on. Each variable must be declared, right? So differently, before you use a variable, you have to declare the variable name, and you have to give it a type. So for example, if you want a variable called count, and it's going to hold a type called int, you type in int count and semicolon. Semicolon says now I've defined the variable, so I can call that variable again and utilize that in my code. Same with a Boolean gun. And then you can see that it's got a semicolon. You can also assign the value at the same time. So you can say count, you can do it like this. You can assign it first, then you can populate that variable later by saying the name of the variable equals the value that you want to give that variable. I'll give you some examples next week. Or you can do it at the same time. You can say the int type of the variable count is going to be equal to 1. So you can assign it at the same time that you're generating the type as well. Any questions on that so far? Oh, what time? Quarter past as far as I remembered. But, yeah, no worries. Okay, so we'll call it a day for now. I'll double check the times because I think the recording isn't working as it should. And have a good week, and I'll see you guys next week. Remember, labs start next week as well on Monday. Thank you. No, that's all right. No, I've got to get another 500 students.